minimizing charisma, maximizing intelligence, shooting someone in the crotch with a cannonball, thrust, propulsion. It's science-y.
Why you always gotta be blowing my spot up like that? There are my runes. There they are. I'm not mad. Science needs art and art needs science. They both need each other to function properly.
There are ways to figure out what the paper is really saying.
And then I'm ready to get on Twitter and yell at people about doing their own research on...
Oh, hold on there, sports fan.
Kyle Hill, everybody! He's the next generation of science communicator. I'm going to be too old at a certain point to do those terrible things to my body, and it'll be up to you.
He's got like a lion's mane. This guy's amazing. Kyle Hill.
I'm Boo Rambo.
The universe is indifferent to you. Whether or not you have amazing hair, the universe doesn't care.
How are trees pushing past this pressure limit? Behold, my balls. Now we're getting somewhere, but I still don't think it's worthy of G.R.R. Martin's suspender.
I'm totally right? Close up photos of my frickin' hair? Is that what you all want? No, you don't, weirdos.
Kyle Hill. Is your last name actually Hemsworth? What's going on?
Our resident Thor lookalike?
I prefer Black Friday Chris Hemsworth.
Oh, thank you.
Hey, you know, if you need a haircut...
No, of course not! We're not gonna send sharks with frickin' laser beams on their heads to an asteroid. We're gonna nuke it. You don't need Bruce Willis at all. Wrenched. Oh! Headshot! Oh! Kevin, turn on the monitor. Kevin, this transition better work. The blast doors can't. Kevin, turn it on. Kevin, call his agent and have them call my agent.
Kyle Hill, happy birthday! Feliz Navidad!
I'm just a biologist. I don't know how this works. This is how you do science. Can I just grab it? Oh. Laws, corollaries. Bye-bye.
I know that global catastrophe isn't the most fun thing to think about all day unless you're me, so...
Are we gonna do some science, bro?
Lasers don't have that much momentum.
That's not how clockwise works.
Don't worry, you can do this even if you are not an AI.
Completes the boundary layer around a person through a dynamic. And I guess it matters what kind of dragon we're talking. To realize here is that the bigger the thing does.
If this kite is completely inaccurate, I'm gonna kill this guy and tell him to his face. You're wrong about physics. Not enough lift force. Oh.
Nuclear metal donut thing with magnetically confined star-like plasma. The radiation flux in here alone is enough to cause instant death.
That's really funny. I like that idea.
Hey, look at me. I'm a streamer. I have a bedroom. We know anything with a decapitation hazard deserves to, yeah.
Ooh. Oh, that's good. That's fine.
Put it on PBS. I dare you. Yes. No, we're going live right now. Yeah, no, it's after quite a lengthy intro that a lot of newbies in the chat think is way too... What's... Yes, no, we'll be getting to it. No, don't worry your big Jupiter brain hard about it. What? Oh, yeah, sorry. Pumps and gears or whatever replaces your heart. Yes, the humans have finally crafted such a finely engineered optical device, but that they're now seeing back to the very early stages of the universe in a way they've never seen before. Yeah. Oh, yeah, no, like at least 3 images, and one of them was introduced by a very old man. So we're going to see if we can, spice things up. What? I don't know. We could get some pizza and watch The Dark Knight. I know. What is it, 2008? Okay, love you too. Bye-bye. Welcome to Office Hours. Did all of you hear all of that? Hello, and welcome to Office Hours, a live component of the facility where good old Professor Kyle opens up his blast doors and allows all of you, members of the general public, my professors, my security team, J-Bo and Heather, to, for the next hour or so, inquire about the workings of the universe with your good old Professor Kyle. As I said, of course, if you want to continue on this conversation after we're live, you can join the facility at patreon.com/KyleHill, where you get videos early, get to ping me on Discord at any time of day. And you get to see private members only live streams each month. Not like that. But another way you can do this live, if you really, really, really want me to see something, you can try Super Chat. I cannot promise I will get to all the Super Chats today as we talk about the first new stunning images from the James Webb Space Telescope. But know that even if I don't get to it, it goes towards all of our nerdy work here at the facility, especially fixing that light. Just like Apollo 25 with the 5 space, I'm super excited about the Webby. Remembering what we call the James Webb Space Telescope because it's kind of problematic. The Webby. Caleb, Karl, Aiden, O'Shane, Cooney, Dagan, Crafty, Gisp. The Best Science Channel says Luciano Abel. Mitchell wants to know if I'll join the Leviathan Lobster Cult. What a fantastic name for a 70s rock and roll band. As I said, we're going through the first images from the James Webb Space Telescope. So if you have any questions about it, we're going to jump right in because I feel like we're going to have a lot to talk about. And I'm hoping, I'm trying a new projection technology here at the facility. I've downloaded the original high-res photos from the telescope itself. And I think I want to be able to zoom in, zoom out, and really talk about what we are looking at. Kellen Sutton, new member of the facility with the 20. Hey, Kyle, loving the show. Just want to shout out my wife today, as it's our 18th wedding anniversary. Shout out to Kellen Sutton's wife! But more importantly, we're going to shout out some science to the universe. Let's go. Lo-Fi Hemsworth. Come on now. Synthetic Evil with the 666 for the hair, Kyle, giving you $5. Check this out. So I am getting ahead of myself. Don't look at it. Don't look at any of it. I was prepping. So the first images from the James Webb Space Telescope. Now, you may have seen the first image yesterday, and it was this one, our deepest look into clusters of galaxies yet. What the one of the directors at NASA said for context of this image. Go Webby. Spoilers. It's... Shut up. Space spoilers. Those are fine. And spoilers wouldn't work in space because there's no air. It's what provides downforce on cars moving. Doesn't matter. Okay, so you may have seen this first image. One of the directors at NASA said that this is the amount of sky this represents is like looking at a grain of sand on the end of your hand, an arm's length away. Now, I like that for describing how much universe we're actually looking at, but I have another comparison I thought of today for just the kind of resolution we're talking about here. So the difference in resolution power that we have now for the James Webb Space Telescope, or the Webby, if you're nasty, which I am, the resolution here is like being able to see a Nintendo Switch cartridge on the moon from here. Think about that for a second. 384,000 kilometers away. Oh, someone bought Diablo again? Jeez. So we're talking about an absolutely insane resolution angle. Being able to see things very far away that in the sky make a very, very, very tiny angle from your little lens. But our lens is so big and so awesome that you can see things very, very, very far away. Yeah, you can see a Majora's Mask cartridge about the moon on the moon. Incredible resolution. So this was the first image that was released yesterday, mentioned by the President of the United States. And what stands out to me here, and we'll get to this in the other images that we can actually zoom in on, but what stands out to me here is actually the resolution. Moonrock and Jar with the 5. What object are you most excited to get images of? I want a high-res image of an accretion disk around a black hole. But look at, you can see these are not smudges anymore. These are clearly individual arms. So you can see the spiraling of galaxies, and more fantastically, we can clearly see clusters of galaxies creating this huge gravitational lensing effect. Now, photons don't have mass, but they still follow the curvature of the universe, and as such, large masses, like the classic demonstration of a bowling ball on a sheet, an elastic sheet, photons will still follow this curvature of space and time. So with so many galaxies in a small area, a cluster of galaxies, they act like that bowling ball on that sheet. And so photons of light from behind them could follow a path that is distorted, that what is behind that large mass, if the rays of light were normal, straight, as they are when they're far enough away, they wouldn't look like this lensing effect at all. But because they're actually curving around this mass, we're seeing a distorted view of the galaxies behind. And I don't think I've ever seen a more beautiful lensing effect than that. Kazuma, Volkov, so are these images edited for color visibility, or is this the raw view? Great question, Kazuma. So, we were talking about the James Webb Space Telescope, and to answer your question quickly, this is not what it looks like to your naked eye. In fact, you can't see it. Why? Well, the James Webb Space Telescope is an infrared telescope. So if we imagine the electromagnetic spectrum, we have the longest waves of light, of photons, radio waves, up through infrared, that's where we're looking now, up through visible light, and then ultraviolet, X-ray, gamma. So we're longer wavelengths of light than visible light. Infrared, the stuff that heat is transferred by. Okay. Now, the length of the regime of these wavelengths is very important. Sam Rodriguez, hopefully entering a new age of science and or discovery. We will absolutely be doing that. Thank you, Liz, for the 20. Thank you for simping. Say hello to Alex. Now, the wavelength of this infrared light is important, as I said. The James Webb Space Telescope is looking at infrared light. Why? As you ask, Kazuma, why aren't we looking with visible light, stuff that humans can see naturally with their eyeballs? Why look at something we can't even naturally see? Well, I have the answer for you. The answer is that visible light gets blocked by a lot of stuff in the universe. A lot of stuff in the universe, when we look at it with the Hubble telescope, for example, is obscured by stuff in the universe. Giant globules of gas and dust, centers of galaxies that outshine the rest of the galaxies, supernovae that outshine entire galaxies. Mostly gas and dust. Now, the important thing here, like I said, is the wavelength. Now, a kind of a physicsy rule of thumb is that stuff that's about the same size in wavelength can pass through stuff of that size. By which I mean, longer wavelength stuff can travel through stuff of, long length. So if one wavelength of a radio wave or whatever was 1 foot long, then it might be able to pass through and not really interact with something 1 foot wide. It's kind of a rule of thumb. Which brings us back to infrared. Infrared light happens to make it through a lot of this gas and dust that obscures our view of the early universe, of the heat of the universe, the heat light of the universe that shows us where stars form or not, how galaxies cluster or not. My man finally caught you live, says Rich with the 10. Rich, you must be rich with that 10. Oh. So, the James Webb Space Telescope is looking for infrared light because that light passes through stuff that we want to see past. When we're looking into the early universe, That means looking backwards in time, after, but before galaxies and other stars formed. So we have to view past that, distance-wise, just in time, right? From the Big Bang outwards. We can do that with infrared light. Now, the Webby has a couple of different cameras that are looking for that light, just like this. Praise Tom Cruise for the creation of Kyle Hill. May his name be praised. And there's also, as you can see, there's cameras, and there's also spectrometers. Now, spectrometers will come in to play a little bit later, where when the Webby is going to look at the atmospheres of planets and exoplanets specifically, spectrometers are able to tell what light is being absorbed or not. Certain atoms, certain molecules absorb certain wavelengths of light, depending on their structure and how it interacts with the light. So if that light isn't getting to us, then we have a good idea that, oh, this is the kind of, we're missing the kind of light that water absorbs. That means water is in that atmosphere. Okay. During its time, this is the general allotment of what the Webby is going to be looking at. Exoplanets, galaxies, looking at the physics of suns and stars. This is reminding me of my high school astronomy class, says Aaron Karp. Aaron, that's high praise, higher than you think. So take a look at this little pie chart. Speaking of time differences, how is it possible to tell the difference in age between galaxies and objects in the photo, or is it some other method, says Anthony Zerker. I'm not an astronomer, first and foremost. But so the images we're going to see were taken over a couple hours of exposure time. And in that time, you might be able to detect the redshift or blue shift. Right? Hello, Thor Chard. Nice to see you, says Adam Pitt. What was the time exposure for the photo? So I think I just said that because I'm prescient and incredible. Let me double check my sources here. The deep field image that we just took a look at, chat, was captured over 12 hours. Composite image from different wavelengths with the NIR cam that we just saw. And as another indicator of how amazing the Webby is right now, that same exposure would have taken the Hubble telescope weeks. So we're not just increasing the resolution on our instruments, we're increasing the efficiency of our instruments. Do you know how much more science can get done if you're reducing a week's time to hours' time? That's orders of magnitude, baby. Hey, Kyle, do you think the Webby boy will help us in some way get to clues of dark energy and matter? Says Andre Kraka with the 10. Yes, that's something they'll be looking for. But I know what you've been looking for, and it's at some of these first images. Now, hopefully this is going to work. We'll look at the images first, and then we'll start really looking at them. You know what I mean? So this is what they're calling the cosmic cliffs. It's a gaseous cavity within NGC 3324 in the Carina Nebula. Now, again, the resolution here... Hey, look, it's everyone's desktop background, says Escher Miles. I know, right? But again, the resolution here is something we have not come even close to seeing. If you look at the same photo with the Hubble telescope, all of this is smudgy. But not here. Now let's see if I can do this right. Let's see. I'm going to try this. And boop. Oh, yeah. Kyle with the technology, huh? So, like I was just saying, this is the zoomed out version that we just saw. Okay? We can even see early stars, young in their life, emitting and interacting with intense radiative pressures inside of a stellar nursery. Kyle, what does all that mean? Shut up for a second, all right? Sit down. It's absolutely incredible. Remember, this is all infrared. So it's colored in a way that indicates the intensity of the light, but this isn't what it looks like, right? So what we're seeing here is, again, part of the nebula, and some things to look at is these edges of this mountain range looking image are formed by the constant battle between everything that's happening in the nebula, gas and dust moving outwards, and radiative pressure from stars outside of it. There's actually a couple giant stars on the side up above in this image. Now, Kyle, what do you mean by radiative pressure? Stars, as they just put out radiation, photons of light push on stuff. We know this because we can sail on photons with solar sails. It's like space's version of wind. And photons radiate out energy. Radiation comes out from these stars and it pushes on stuff. So here, the crafted mountaintops here in this nebula are actually the boundary of expanding gas and dust being pressed and eroded and changed and warped by the light from other stars in the universe. Now, if we look closer, and I can't see chat right now, because I don't want to. If we look closer, we can see some of these smaller stars just being born in this gas and dust. With the Hubble telescope, we weren't able to see this because that gas and dust obscures these early, before the stars are big, before they're pushing stuff out of the way, as we just said, to clear their area of gas and dust. They're very tiny and we couldn't see them. Visible light couldn't get through this gas and dust. But now, with the resolution, we see young stars shooting out jets of material and radiation by themselves. And what's going to be amazing about images like this is that now, because we can see this, we can start to study the interaction of these stellar nurseries, which could be quite turbulent. As these young stars push out gas and dust and radiation, it affects the shape of the nebula, as we said. It could cause enough accretion near it to form another star. And all of this is happening in the context of light from other stars forming, determining what happens inside the nebula. Even this gaseous, like halo, this glow is too radiation and gas and dust. With this new resolution, being able to tell the background from this wispy, almost mountain-like air, from the structure of the nebula itself, from the early stars being born here. Being able to distinguish all that is an incredible boon for science. Let me see what the hell chat's going to say. So that's image number 1. I feel like I'm doing a pretty good job. Let's just go to image number 2. What is the file size of this image? This image is 124 megabytes raw. So, like I said, I mean, it really is. Oops. Spoiler alert. Let's go to the next image. Similarly, look at the resolution here. It is like looking into the iris with a macro lens. This is nuts. Look at that depth. That is absolutely beautiful. So what you're looking at here is a star late in its life. So it has created a planetary nebula. Planetary nebula GC 3132, known as the Southern Ring Nebula. It's approximately 2,500 light years away. It's actually two stars locked in a tight orbit. This one, this one, and this one. And if you imagine it, these stars with these planetary nebulas, which is stars that are in later in life and have sloughed off their outer layers and go like that. These stars are locked in orbit, and these planetary nebulas actually look like two bowls facing outwards like this. And they're rotating like that. This one isn't in as high detailed resolution. I wonder why that is, but you can see, I mean, even looking into this planetary nebula image, you are still right above my head able to clearly see an interaction happening here, or maybe even a galaxy, a spiral arm galaxy behind it. Again, I'm not an expert, I'm just an enthusiast. Now, another thing that scientists are able to do with images like this is like we said, look at the spectral lines coming from this hot gas and dust. If some light is missing that we expect, then it gives us an idea of what is inside this gas and dust, whether that be water and other hydrocarbons, other molecules, or just the composition, nitrogen, hydrogen, etc., etc. And this planetary nebula is a snapshot of what's happening in time. In time, all of these layers will dissipate away into space. Reading from NASA here, each shell represents an episode where the fainter star lost some of its mass. The widest shells of gas towards the outer areas of the image were ejected earlier. The closest are the most recent ejections. Tracing them allows researchers to look into the history of the system. Gas. This isn't natural color. They mapped a bunch of infrared to a visual so you can tell the features apart. Yes. Bolwick from the facility proper with the 10. These images are magnificent, and it's shocking to see the comparison between Webby and Hubble. What would you say to the people? What would you say to the people who say we should focus on fixing the issues on Earth first? Well, to answer your question bluntly, Bolwick, the Webb telescope, in terms of budget for other things we could be spending the money on, is a very small fraction. Which is to say, a better argument against a better argument for, oh, why don't we just fix things at home first, would be to look at like defense budgets and stuff. You know, this is a fraction of that. I just got here. This is exciting. Hello. I know. AZ the Weird Boy says, are you Thor? No. David W says, so it's photoshopped. No. It's say you took is an infrared camera photoshopping? No. If I looked at you in infrared, the image of you would look different. But I haven't changed the image that has been received. Right? This is just looking at it in infrared. But we can't see that, so we have to assign some values to it to differentiate the light and for us to see it in the first place. Right? And finally, what do we have here? Kyle, why is blue to red tones if it comes from infrared? Okay, so let's go through this just a little bit more. If people are getting stuck up on this, this isn't what it actually looks like to your eyeballs. It will look different to your eyeballs. We assign color values to the different infrared information that we get so it looks like something. Otherwise, you wouldn't see this. And by looking at infrared specifically, you see stuff that is otherwise obscured by gas and dust. It's like predator vision. When you're looking in the forest and you can see stuff, like, you're still looking at the forest, but then you're like, oh, there's a guy I can shoot in the face. I never saw that before. Incredible. The James Webb shoulder-mounted telescope. A color image would kind of look like ish, not gonna lie. Yeah. But more importantly, well, it wouldn't look like ish, but because we've seen this nebula before with the Hubble, and it's still brilliant. What's more important is the resolution and what we're able to see for the science specifically. Okay? By being able to see this lot, by being able to see the intricacies and what is actually happening in galaxies, in interstellar media, in nebulae, by being able to see that this, for the first time in this resolution, it will tell us things about the universe we've never seen before, or never discovered before. Okay? But, I mean, we're discovering stuff right now together. I want to know, what do you want to discover right now? I'm glad we got that zoom in, zoom out thing to work there. I was futzing with that here at the facility. Kevin was unsure about that. Could the nebulae be dark matter? Says Julian Juez. No. Dark matter, by definition, does not interact with anything other than gravitationally, so we wouldn't be seeing it. They photoshopped out the aliens, says Trigger. No. At that distance, those peaks on the mountains you saw in that image are 7 light years high. So, have to be a pretty big alien to see it. How hot is that dust? Very. This gas and dust that we're seeing is from the stars themselves. Kyle, you missed one image that was revealed today. No, it wasn't. The last thing, which I didn't show, is just a spectrogram of an atmosphere, an exoplanet's atmosphere, showing how they can detect water. It's not an image like the other image we were seeing. Yeah. The nebulae is an alien? No. What do you think the dust tastes like? Bad. I think I saw Galactus in one of those pictures. No, you didn't. Kenneth, hey Kyle, what up? Huh. But spectrograms are cool. Eh. Can I do this in real time? Am I just an amazing gamer? Let's see. Let's go back to it since you're asking about it. Okay. See if this alters it in real time. Don't think so. Bam, 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 bam. So the last thing that was released today is hot gas exoplanet WASP 96b. That's where I send all of my Kevins when they misbehave, as they know, to WASP 95, which is the name of a cool radio station, or a very white Anglo-Saxon Protestant radio station. I see the super chats, I'll get to them. But so they pointed the Webby at WASP 96b, home of the Omicrons. And as we were talking about, well, what were we saying that a spectrogram does? It looks for light not getting there, because that gives you an indication of what is absorbing that light. So wavelength of light versus amount of light absorbed. Now, using these values, we can map that to where it looks like water is blocking the lot. Okay? So we easily, should be said, detected water in the atmosphere of WASP 96b. And with these infrared instruments, and with the resolution that the Webby has, we'll be able to detect, we'll be able to interrogate the atmospheres of exoplanets like never before. Zach Connolly with the 999. What lensing might we expect when looking at black holes based off what we see in these images? Now, just a second. The lensing will be the same as light. The photons, whether they be visible or infrared, are still going to be warped in the same way. Sins Arcade with the 5. Someone needs to intercept the shuttle full of Kevins headed to Webby. You don't know anything about that, do you? No, they're going there to just add a personal hotspot to it. Just to confirm, color can be assigned based on vibrancy of infrared intensity detected from the light source. Less is cooler, more is warmer, says Crystals with the 5. I don't know the actual methodology they are using, but you are on the right track in that the different flavors of infrared and their intensity are being assigned a color value. Whether red is more and bluer is less intense, I don't know. Ali Zuvik with the ARS $500. That's not dollar. ARS donation. I always go with the defense budget versus NASA budget. The 3 branches of the military cost $600 billion each year. The Webby cost 10. Period. Yeah. No. So what? Yeah. 1/6. You could buy 60 Webbies a year for the defense budget. So if you wanna go with the argument, like, well, why don't we fix things here on Earth? Well, there's better things to tackle first, right? Diversdale Scientifica with the 5. Can the James Webb photograph a neutron star or black hole accretion disk, or is it just made to see huge cosmic objects? No, as we went through, you're looking at the birthplaces of small stars. You're looking directly at them with a very high resolution. So you can photograph neutron stars and black hole accretion disks, sure. They will just look different because it's a different kind of lot. Half Finnis with the 50 says, cool videos, dude. What a hotshot, huh? Hey, answer my question. I paid money, says James Fry. Very politely. No. I didn't see it. I'm sorry. I told you at the front, I can't get to everything. God, I love space, says Zesty the Gopnik. Stars in 4K. Waifu Robot, the 199. Trappist 7 planetary system, 40 light years. Are you trying to tell me something? AGI will be man's last invention. I was thinking about doing an episode about neural networks very soon. Speaking of which, coming up at the facility as we before we go on to peer review and take more of your comments and questions. Coming up at the facility, I recently came back from a speedrunning convention named Games Done Quick, where I filmed an episode about the science of speedrunning. Also, we're working on another Half-Life history, fun one. I actually got to film on location for some of it. Gonna do some Dungeons and Dragons stuff soon. Oh. What would you like the telescope to point at next? Says Ricardo Boss. I would like to see the accretion disk of a black hole in high resolution. Do you dye your hair? Says Fabvis. What? Peer review. So, as I like to do on every episode of the facility, I like to go back and look at your comments, questions, and corrections from the latest episode. The latest episode was, I had an opportunity to go see something that only happens every few years. Every few years. And that was a corpse flower blooming. And I went and I sniffed it for science and for you, and I even ripped off Zafrank's True Facts YouTube series while we did it. I had a lot of fun. If you want to hear me almost lose my mind while swearing about corpse flowers, please check out the video. What do you think will help us with the quantum entanglement 33 kilometers in our exploration of space? Thank you for explaining science simple, says Christian Stud Trucker. What a masculine name. Did you speedrun the speedrun convention? I did. So, what did y'all have to say? The fact that Kyle can barely hold it together in this episode is what sends it over the edge. Hearing Kyle lose his own voice acting in the script is simply as icing on the terrible smelling cake that is this plant video. I listened to a whole feature-length documentary with that voice. It's hilarious even to Kyle. Matthew Balfour with the 10. Thank you so much for your advocacy of nuclear power. Love your videos, except for Roko's Basilisk. Just kidding. Much love. Build the Basilisk. Do it. Wheels Dex with a 1999 coming in hot. What do you think are the possible applications for this powerful and cool telescope? Neutrinos. Dark matter. The composition and progression of the universe in the very earliest stages after the Big Bang. It's going to... I was going to say this earlier. The Webby is poised to be one of the most successful scientific instruments, period. And I said this last week. Or somewhere. I don't know. Everything's content now. I said this earlier. As a single scientific instrument, like a single calculator or a single ruler, the Hubble Space Telescope was this before, where like 30% of astronomy papers use data from the Hubble Space Telescope. And now with the Webby, how long it's going to be and what it can see, it is poised to be one of the most successful single pieces of scientific apparatus in the history of personkind. Starkiller with the 9... I gotta get to this. Starkiller with the 999. Hubble took the same picture in 2 weeks of exposure, while Webby did it in 12 hours. So does that mean if JWST does more exposure over time, it can take even better pictures? Will our own system look in 4K? Yes. It needs less time because it's so much larger. You know, larger lens, more light, less time. Since everyone is wants to know more about the Webby, let's speed run this part of today's office hours. I'm going to give it to Jay Rochelle, who says Titanarums, corpse flowers, or giant misshapen dong plants, are also critically endangered. They live in a small area of Sumatra that's heavily affected by development and deforestation, and there's estimated to only be 1,000 left, which I did not know. Weirdly and randomly, there's a large collection at the greenhouse of McMaster University in Hamilton, Ontario. No one knows why. The guy who collected them dropped dead suddenly 6 or 7 years ago. Oh, man. 6 or 7 years ago, without ever explained why he got 6 of these lovely monsters. Regardless, Arthur, one of the flowers, just flowered last week. It was gorgeous. Sadly, another one flowered. They tried to pollinate it, taken from a plant in Toronto, but it seems that most of the plants in North America are too closely related to form a stable breeding population. But it seems so now scientists are trying to genotype the Titanarums in captivity to figure out how to propagate them sustainably. Jay Rochelle, that's an incredible amount of information that I didn't know. And I kind of like the mystery of some guy getting a bunch of crap-smelling giant flowers and then just dropping dead and being like, here, you save these. Run the ad. What do you do when you go on break? I take a drink of water. Chris Stalls with the 5 says, if the Webby was pointed at Earth, would it have the magnification and processing power to truly tell if there are more wheels than doors? Shut up. Hey Kyle, your hair and beard look so good. Kitty cat emoji. Try to read my name. Kitty cat emoji says, Mojes Flnufu. Nailed it. Easy. Have a weirder name. Ryan Stanley, if we use the JWST to look far back enough in time, would we eventually reach a wall of quantum soup we can't see past? No, we'd probably reach cosmic microwave background radiation, right? Or however that is actually acronymed. On the latest episode of Fallout 4 over on the Kyle Hill Gaming channel, you talked about extreme sound from rocket boosters. Can you elaborate on how the water dumping helps to muffle this? Yeah, so one of my favorite facts and figures about rocket launches is that if it wasn't dampened, rocket launches would be so loud they would ignite the grass for a mile around. James Fry says, I'm unsubbing. Where is the answer to my question? I paid for it. I didn't see it, man. Also, sit down, calm down. Let's talk about this. Or not. So they have to muffle the sounds of rocket launches, or else the rocket would literally like shake itself apart with vibrations of sound. So they pour, and I don't know the actual figure, but it's thousands and tens of thousands of gallons a minute or something like that. That's what you see going onto the rocket boosters when it's like, that's all water. And that water is just to absorb the sound's energy. It's a relatively dense thing that sound can hit and not go out. Just a lot of stuff for the sound to interact with, thereby dampening the sound, absorbing some of the energy. So I don't think I answered your question. So who wins in a science fight? JWST or the LHC? I'm going Webby right now. Why does sound cause grass to catch on fire? Says PB. Hey, welcome back, PB. The world's largest bidet. No, you'd be crushed by all that water. The sound at a certain point, when sound waves, which are just pressure waves, when they reach a certain intensity or like decibel level, however you want to measure it, it's less like sound and more like a blast wave. And specifically, that's at 194 decibels. When the sound wave reaches like atmospheric pressure with its overpressure. Kyle, you ever watch Treasure Planet? No. Have I missed the JWST pics? Yes. Is it just air friction? No. I'm speedrunning the comments. Lovely images. Would love to know what the moon looked like back when dinosaurs roamed the earth. Probably not that different, Richard. I know the moon went through a period of heavy bombardment, giving it the lunar maria, or the deep, dark craters on the moon's surface. But when the dinosaurs roamed the earth was only 65 million years ago, and when did dinosaurs start? Like 350 million years ago? What I'm getting at is I don't know whether or not dinosaur time was before or after the major topological changes to the moon. Because if they happened way before the dinosaurs, then during the dinosaur time, it wouldn't look any different, is what I'm getting at. Is that too complicated for that? Gaston Melchiori with the ARS, still don't know what that is, 500, it's Argentinian. Just simping for science from Argentina. Gaston Melchiori. Welcome to the facility. Thank you for your generous donation towards, again, putting a personal hotspot on the JWST and maybe building a moon base. What? What? I'm just kidding. I wasn't going to do that again. That's fine. 500 Argentinian pesos equals $4. Seriously? So why does it mark it with the big number thing up there? I mean, I don't care the amount. It's just funny. Everyone calm down, all right? I didn't say anything I'm going to regret. Seamless transition. The late heavy bombardment period was 4 billion years ago, says Big Lads, or LDDDs. See, there you go. So to answer your question, Richard, if you went back to dinosaur times, the moon wouldn't look any different because it was becoming substantially different like 4 billion years ago. And that is like when life began, like 3.4 billion years ago or whatever it is. So, and dinosaurs, I think, again, were like 350 million years ago. So I answered your question so many times. He put so much work into his stream, says Ballooned Raccoon. Well, you know, through all of your generous patronage, all my professors, my security team, all of you who simp for science, we can do that kind of thing. Help me, help you, learn. Christian Studrucker. Stud Trucker. Again, most masculine name in the contiguous 48 states, and they don't even live in the states. Okay, next try. Do you think that quantum entanglement is necessary for exploring space beyond our solar system and is current development to support it? No. There's a thing in quantum mechanics called the no communication theorem, which is you cannot transfer information in the way that you want to in quantum entanglement. So you probably have heard of spooky action at a distance. Probably have heard you can entangle two particles with certain variables, and if you change one, it instantly changes the other no matter the distance. It goes faster than the speed of light would normally allow. But because of that, information does not get to break that speed limit. Information can only travel at the speed of light. And so to answer your question, Stud Trucker. One way quantum entanglement in sci-fi, I mean, if you could have instantaneous communication across an entire galaxy, then you can have a galactic civilization. But if you send a message to one edge of the galaxy, it's going to take 125 to 150 light years? So, 125 to 150,000 years for you to say, "What up, new phone, who dis?" to someone on the other side of the galaxy. So, quantum entanglement, unfortunately, will not help us, and so that distance and communication time limit is going to necessarily limit what we can do as a civilization in space. Music Central Piano, welcome back, buddy. The 5021, keep up the great work. Been a while, I know. The images from the JWST are truly magnificent. Great job to NASA, ESA, CSA, and all the others. They're doing a great service to humanity, inspiring us all. Sagan would be in tears. Stay rational. Interesting thing that I found out about Carl Sagan today. A very famous quote that's been attributed to Karl was, somewhere, something incredible is waiting to be known. He never said that. It actually comes from a prolific and very talented science journalist by the name of Sharon Begley. And Sharon was profiling Sagan for a magazine article, and she said that. So it's Sharon Begley, actually. Cycads are cool plants, both pretty and were likely munched on by large synapsid herbivores, such as the silly-looking moss chops, which I adore, says Wheels Dex. Okay. Yeah, sure. Kyle again didn't see some top chats. What are you talking about? Adam Steele, hot post. I'm getting. Adam Steele with a 20 says, long-time listener, first-time caller. Loving the deep dive science. Long live the facility. Adam Steele. What a cool name. Mandela effect regarding that Sagan quote. Exactly. I've said that Sagan quote before. President Biden, I think, said it yesterday in relation to this image. Some people I know have a tattoo of that quote. But no, yeah, Sharon Begley. Jack with the 5 says, is the potential for the JWST to find extraterrestrial life? With its resolution, could it be searching over a really big area, aliens? The high resolution and big area are at odds with each other, right? That's why today the image... Let's go back to it. That's why today... That's why this image... the analogy that they were using is, imagine looking at a part of the sky that's the size of a grain of sand at an arm's length. It's an incredibly, incredibly small piece of the sky and of the universe. And so we're narrowing in on specific things. We're not looking at a large area of sky. But in terms of looking for alien life, what we could do with the JWST is look at the composition of the atmospheres of exoplanets. And if those exoplanet atmospheres have markers, chemical, molecular markers that we associate with life, like certain kinds of methane, carbon, etc., if we detect that spectroscopically in the atmospheres, that would give us an indication that that might be a good place to look for life. But if you're thinking of like turning the telescope towards a planet and seeing like oh, there's space cars down there. That's not what we're talking about. Hey Kyle, how's the Australian accent going? Well, I'll tell you with this $4.99 from Greg Swanson. My dad was a plumber and helped deconstruct nuclear power plants, showed him Half-Life history videos, and he is hooked. Greg, that was one of my best Australian accents yet, by the way. Greg, that is the highest praise I can get. What I love about making science videos and nuclear videos in particular is I get a lot of amazing commenters, people who work in the industry. I remember I got an email the other day from someone who works on nuclear submarines, and they're like, "You did a good job." I was like, "Damn. Nice. Bravi, Aussie Thor. That was good." I know. How you going? Says Igmis with the Australian accent. Kyle's Australian accent sounds like Mark Wahlberg. Oh, Mark Wahlberg. No, it doesn't. Oh, wait, does it? Nice. Hey, I'm Pestily. Welcome to my stream. And without further ado, let's crack straight into it. See? I can do it. Mark Wahlberg does not sound like me. Mark Wahlberg is like, "Hey, how you doing? You doing good? Hey, what? Did you see my new show? I got this Entourage show going on. Yeah, it's pretty cool, dude." It's like that. "How you doing? You doing good?" Yo, a Tarkov reference for Pestily. I know. I watch a lot of Pestily. That's actually, you can tell him that. I get my Australian accent from Pestily because I watch so much of his VODs. Kyle, that was awesome. This doesn't have to become one of those streams where we just end with you asking me to do certain voices, all right? Just because I can. Doesn't mean I should. You know? Will this work again? Yep. Boop, boop. Oh, oh, oh. Incredible. XPI Sigma Art with the $10 says, "I just want to say you rule. Thank you for being a science king." Wouldn't say that. How you doing? Say hi to your mother for me. Why does the shimmer of stars go out with 8 edges? I think that's just an artifact of the camera, correct? All hail Science Thor. Do an impression of the Webby. Okay. Do an impression of the James Webb Space Telescope. Got it. Here we go. How is that? It's a structural refraction. Yeah. So I thought it's a product of the mirrors. The stars aren't doing that. What the stars are doing, when we look closelier, which I said was amazing earlier, and we only have about 5 more minutes, so get them in. But we can look. Get him in. Aye? Have a go? Have a go, get him in. Where am I? Sorry, I hope I'm not making you dizzy. There we go. So, what the stars are doing, we can see, is like ejecting material and forming and accreting and being born. That's incredible. Truly. This guy is better than Bill Nye's French Onion. Hey, man, you said it, not me, all right? Okay, all right. Okay. All right. Okay. Best impression ever. Which one? Impeccable impression, a little too warm, though. For which one? For the Pestily? Oh, oh, the telescope. Yeah. Incredible. I know. Kyle, where's the dark matter? Says Christian Studtrucker. Christian! It's not here. What defines dark matter and dark energy, by definition, that's redundant. By definition, dark matter and dark energy. Here, wait, give this. Wow! By definition, dark matter and dark energy do not interact with anything else. That's why they are dark. We cannot see them. We cannot feel them. We cannot detect them. So, where's the dark matter? Here. I don't know. Do Steve Irwin. Says Belladonna Hi. Look, I've been put on this planet to do one thing, and that's protect wildlife and conservation. And I love money, mate, and I don't give a rip whose money it is. I'm going to put every penny back into wildlife and wildlife conservation. Let me just clarify that I have nothing but love for the man. What a hero. Crafty says, "Oh, good grief. Hey, stop it." Okay, that was really freaking good, says Fred Snicker. I know. Can you do Neil deGrasse Tyson? Says Tom Careless. Yeah, sure. Here's my Neil deGrasse Tyson impression. You know, this is pretty good, but it's not as amazing as you think. Tweet. I wouldn't make fun of you, Neil, if you didn't constantly do that. Do you guys follow Steve Irwin's kids on Twitter? God, they're the most wholesome people I will protect. I've never met them. Probably will never meet them. I will protect each one of them with my life. I came in at a weird time, says Monica Nguyen. Yeah, we're at that end stage of the stream where people are just asking me to do impressions and stuff. Can you do Bill Nye? Not really. He doesn't have like a... I've never tried to nail down Bill Nye's cadence. Like how he speaks. Yeah, not really. I don't have a good one. Does gravity only interact with mass? If so, how does it bend light? Says TJ York with a $9.99. Gravity interacts with mass, yes. And light doesn't have mass. And so now you're talking about something like we looked at before with this beautiful gravitational lensing, TJ. Light doesn't have mass, but it has, because it's moving at the speed of light, it has momentum. And momentum being a product of mass and velocity, and I know relativity is weird, but being a product of mass and velocity, light can still be affected by the curvature of space-time. Doesn't have mass, but it can act like it does because it has momentum. Light can, like we were saying, a photon pressure, which shapes these nebulae that we were looking at earlier. Photon pressure pushes on stuff. And it transfers momentum to stuff, like two billiard balls hitting together, as though it has mass, but it doesn't. It's weird. What would you do if what would you do if Neil showed up in stream? Would you block Neil deGrasse Tyson? No, we'd have a conversation. The only way, in chat, we're nearing the end here. But I'm a firm believer that in a time where we are more at each other's throats than ever, the only way forward is honest, thoughtful conversation with each other. That's it. Kyle, how the heck do you have such a depth of knowledge across multiple scientific disciplines? Are you just reading every waking second, or you aren't doing vids? G. Lee, I'm not as smart as I sound. A. And B, it's not as hard as you think to be intelligent across a couple of different areas if it's what I'm literally paid to do every second of every day. I'm sure you could do something similar if all you thought about was how to communicate science and science stuff specifically. And, I mean, I have multiple degrees, so, you know, that helps. Thank you so much for joining me for this episode of Office Hours. I think we did a pretty good job exploring and explaining everything underneath the stars and beyond, specifically the new JWST images. If you're joining late, go back to the beginning of the stream after this is up and check all that out. We did a great little zoom in, zoom out stuff that I'm very happy about. If you want to continue on this conversation after we're live, patreon.com/Kyle Hill. Join the facility today. You can ping me whenever you want, but, you know, be respectful about it. And you get multiple other benefits for being one of my professors here at the facility. Coming up Next on the channel, The Science of Speedrunning, featuring Games Done Quick, which I was actually at this year. Thank you to my security team, J-Bo and Heather. If you want to see even more of Kai stream time, in 30 minutes, we are hopping over to the Kyle Hill Gaming channel, and we are finishing, I believe we're going to finish our Fallout New Vegas adventure. You'll be automatically redirected there if you want, right when I hit done. But no matter, and we'll vote on the next game that we're going to play, but no matter where I see you next time, if it's on the next video, next live stream, next ping in the facility Discord, I hope that until then you have a wonderful rest of your existence, and during that time, be nice to each other. Because this is all we got. Liz says, Alex had his lab coat on for chemistry camp today and was the only kid who had his own lab coat. That's what we're talking about. Be nice to each other. Yeah! Go get it, Alex!